Today, we're going to break down a really fascinating new AI model called SAM2, and it's a huge leap forward in solving one of the toughest problems for computers: how to actually see and understand things that are moving.
You know, a single photo can tell you something, but it never tells you the whole story. The real story here isn't just a dog and a ball. It's the chase, it's the action. A snapshot is just one word, but we're about to look at an AI that can finally read the entire sentence of a video.
So that brings us to the big question. How can a computer perfectly cut out a single moving object, like this dog, from everything else, especially when you're dealing with thousands of constantly changing frames? It sounds simple, but trust me, it's one of the most complex challenges in all of AI.
All right, so to really get why SAM2 is such a breakthrough, we first have to understand why this is so darn hard in the first place. What is it about video that makes it so much more difficult for an AI than just a simple photograph?
Well, it's kind of like a tale of two different worlds. AI has gotten incredibly good at understanding still images. Where objects are usually clear, the scene is static. But video, oh man, video is a chaotic mess. You've got constant motion, things getting blocked, motion blur, and the way something looks can change completely from one second to the next. Just take a look at this. In one frame, the dog's head is perfectly sharp and clear, but just a few moments later, it's just a blurry shape behind a chair. Now, you and we can follow that instantly. But for a computer, that's a total nightmare. How does it know that that blurry mess is the same object it saw so clearly just a second ago? And the thing is, it's not just one problem. It's like an avalanche of problems all at once. The object itself is moving and changing shape. It gets blocked by other stuff. That's called occlusion. The lighting changes, the camera shakes. Honestly, any one of these things is more than enough to completely confuse a traditional AI model. So, how do you solve a problem this complex? Well, that's where the solution comes in. A brand new model called SAM2. Now, if you follow the AI space, you've probably heard of the Segment Anything model, or SAM. It was a total game changer for understanding images. Well, you can think of SAM2 as its direct descendant, but it's been totally rebuilt from the ground up to handle all those messy, complicated problems that are just unique to video.
Okay, so the official kind of nerdy term for what SAM2 does is promptable video segmentation. That's really just a fancy way of saying you can point to an object in any frame of a video, and the model's job is to find and track that exact object through the entire clip, while also, and this is key, letting you easily fix any mistakes it makes.
So how on earth does it pull this off? Well, it has a secret weapon, a single core idea that completely changes the game.
The big idea is actually pretty simple. SAM2 has a memory. See, unlike older models that might only see 1 or 2 frames at a time, SAM2 builds up this memory bank of what the object looks like. By remembering the object's appearance from those earlier clear shots, it can find that same object even when it gets blurry or hidden or totally changes shape. Let's just walk through how this works. Imagine you want to track just the dog's tongue. Okay, so you click on it once, SAM2 starts tracking it, frame by frame. But then, it gets confused and loses the tongue. Now, here's the magic. With old systems, you'd basically be starting over. With SAM2, you just make one single corrective click on a later frame. The model then instantly dips into its memory, combines it with your new click, and fixes the entire rest of the video. It's like a true partnership between you and the AI. And this is the absolute key. Because it has that memory, SAM2 never has to start from scratch. That one little click isn't just a fix for one frame. It's a new piece of information that just ripples through the whole video, saving an unbelievable amount of time and effort. So a model with a memory is brilliant, but it has a huge appetite. It needs a massive amount of perfectly labeled video data to learn from, which is incredibly expensive and slow to create. So, how did they feed the beast? Well, their solution is just as clever as the model itself. They built what they call a 3-phase data engine. In phase 1, it was just pure human effort using the original SAM, and it took almost 38 seconds for every single frame. Painful. In phase 2, they brought in an early version of the new model to help out, and that time dropped to just over 7 seconds. Much better. But the real breakthrough was phase 3. They put the full SAM2 into the loop with the human annotators, and the time just plummeted to only 4.5 seconds per frame. I mean, think about that. That is an 8.4 times speed up from where they started. That's not just a little improvement, that's a complete transformation of how this work gets done. And it's what made it possible to create the giant data set they needed.
This whole thing is a concept called a model-in-the-loop system, and it is a huge deal. It creates this powerful, virtuous cycle. The AI becomes a tool that helps humans create the very data the AI needs to get even smarter. So the better the model gets, the faster it can be trained, which in turn makes it even better. It's basically an engine for accelerating its own progress.
Okay, so the theory is great. The training method is genius. But what about the results? Does it actually perform? Let's look at the numbers. So this chart shows how SAM2 does on a key academic test that measures accuracy and consistency. The higher the score, the better. And you can see the previous best models were kind of stuck there in the mid-60s. SAM2 doesn't just edge them out, it absolutely smashes that record with a score of 78.7. That is a massive leap forward, and it sets a completely new standard for this task.
So the conclusion here is pretty undeniable. This is not just some small, incremental update. That one-two punch of a memory-based system and all the data from its self-improving training loop, well, it's created a true breakthrough in AI performance.
Look, this is all fascinating from a technical point of view, but what does it actually mean for the real world? Why should you even care about this? Well, the potential here is huge. For video editors, this could revolutionize what they call rotoscoping, that incredibly tedious process of cutting an object out, frame by frame, painful frame. In science, it could track cancer cells under a microscope or monitor animal behavior in the wild. And for robotics, giving a machine the ability to reliably track a moving object is a fundamental step towards helping it interact intelligently with our chaotic world. And this all leaves us with a final, much bigger question. The story of SAM2 isn't just about a smarter model. It's about a new way of building AI, one where the AI itself helps speed up its own development. So the question to leave you with is this: what happens to the pace of progress when our tools become so intelligent that they can help build the next generation of themselves?